Alright, hey, it's Kylie, and this is my second tutorial I've shot. This is a little physics problem. And it goes like this. Car A is moving towards car B. Okay, car A starts at the position X A naught 270 meters, and car B starts at X B naught negative 35 meters at a time of t equals 0. Car A has the constant speed of 20 meters per second, and car B begins at a rest. What is the acceleration magnitude of car B? Okay, well, this question came with a couple of visuals too. One you can come up on your own, and the other you would definitely have to solve this problem. First of all, this is kind of what we're dealing with. We have car A is driving towards the left, and car B is driving towards the right. Okay, and these are our initial positions, X A naught and X B naught, or X B initial. So the graph you would definitely have to solve this equation is right here, and this kind of shows its progress forward at time seconds. So A naught intersects, or A intersects B at 12 seconds. X is traveling at a constant speed, and B is increases speed because it starts at 0 and then increases to where it hits 12 seconds. And what we want to figure out is what is the acceleration at this point for car A. Okay, so the way I had to look at this is, so first of all we have this position and we have this position. Oh, let me get this up here. Alright, so first of all we have X A naught, which is, let's put the 0 in there, and this is at 270 meters. Okay? And then we have X B naught, which is negative 35 meters. Okay? And which makes sense when we look at our graph, we see that XB naught starts below on our x-axis here, and so as it goes forward, it hits 0 on the t-axis. I could probably put that in there. Okay. So let's see here. So I want to figure out the distance between these two. And if I can figure out the distance between these two, I have a rate. So I can use a formula and I can figure out exactly how long it takes for car A to hit the point where it intersects at 12 seconds. Let's say it's somewhere in here. You know, like I don't know where it's at, but this kind of helped me visualize it. So we'll say 12 seconds, and I want to figure out the distance from A to B, A to B, and then I want to figure out how long it takes A, or what's the distance for A to get here, and then I can figure out how long the distance for B to get to 12 seconds. Alright, and I used a couple formulas for that. We're going to need to use DRT, which you should be pretty hip on at this point, and also there is you're going to want your equation of motion with constant your equations of motion with constant acceleration. There's probably a couple ways to figure it out. I used one of those formulas. So if you don't know about the equations of motion with constant acceleration, I would go maybe look for another video on that, or look in your book. They probably have a table providing that for you. So first let's start off with this portion right here. have a look at the numbers that we have. So to figure out the overall displacement, let's get this right up here. All right. Figure out the overall displacement. Let's say, okay, so to get that change, I'm going to subtract, to get the change in d, or the overall distance, or displacement. I am going to subtract x a naught from x b naught, and that should give me the overall distance. So x a naught is 270. Alright. And x b naught is negative 35 meters. Okay. And then that equals 305. So we have 305. So now we know the distance between here all the way to here is 305 meters. 305 meters. Okay, let's get up in the middle a little more. Okay, so now we got that. Now we want to figure out the distance it takes, how far A goes in 12 seconds. So we can figure out this point right here. So distance from here to our initial point. Okay. So that's not too hard. We're going to use this formula DRT. Where did my piece of paper go? Okay. Put this up here. Okay, so we have DRT. This point of view. So we have DRT, and we want to figure out the distance that A has traveled in 12 seconds. So we know that the rate of car A is going 20 milliseconds. So 20.0 milliseconds. All right. And we know that the time is 12 seconds. Okay, and that'll give us the distance that car A has traveled, which is 240 meters. 240 meters. Okay, so now we can figure out how far car B has traveled in 12 seconds by simply subtracting this number from the overall displacement, which is 305. Okay, so let's do that. So we have 305 meters minus 240 meters. Okay, and that equals 65 meters. Okay, so we know that car B has traveled distance at 12 seconds. It's gone to 65 meters. Oh, there we are. Okay. So now that we have that number, we can go ahead and use our equation of motion, with a constant constant acceleration. I used the one that didn't have the terminal velocity because we don't need that. We don't have to find it. This formula is the change in d equals v naught t plus 1/2 a t squared. Okay. So let's see what we have here. So we know that the initial velocity for car A is 0. Okay, because it starts at a rest. Okay, we know that the time that we're looking for is 12 seconds. Okay, and we went ahead and found the overall distance that it traveled in that amount of time, which is del d, or I called it d earlier, equals 65. Okay, so now that we have this, we just have to plug and chug, and we'll be finding out A, which is what the question asked for, because it wants it's asking what is the acceleration magnitude of car B. All right, so 64, and then 0 for v naught. We have 1/2 times a, which is what we're looking for, acceleration, and then 12 squared. Okay, so this factors down to 0, and we're left with 1/2 a times 144, which is just 12 squared, equals 64. Okay, now I'm going to multiply each side by 2 so I can get rid of the fraction. Alright, so 64 times 2, or I screwed this up, it's 65, I'm sorry. That's fine, so this is 65. Bet you guys are wondering what was going on here. 65, let's fix that, that's 65. Okay, so we have 65 times 2 to get rid of that 2, equals 130. Alright, so now we have A times 144. We can divide out that 144, which ends up 130 over 144 equals A. Okay, so this is our acceleration, but we want to get this, I'm going to get a decimal for this, and our final answer we're going to want in meters squared. So no problem, just plug it into your calculator. Let's go ahead and do that and see what we get. Okay, there we are. Now, okay, so that gives us A equals acceleration equals 1.90. What is that? 2. We'll round it right there. Okay, well this isn't quite the answer we want because we have to look at what our sig figs are, and looks like we're good to about 2 sig figs here, or yeah. So with our numbers, we have, well, whatever. This is physics. Just the answer is A equals 0.90 meters per second squared. Alright, and that should be it. What this tells us is car B's acceleration along this curve is an acceleration of 0.90 meters per second squared. Alright, and that's our solution. Alright, thanks for watching.